All right, starting our notes in first hour, they've had some time to already copy the definitions. The section title for 5.1 is Angles of Triangles. Today's the 12th. Oh, geez, my brother's 48 today, 47 today. Yeah, best get a hold of him. Angles of triangles. First of all, interior angles. The big idea is these are the angles that are on the inside. And for exterior angles, angles creating a linear pair. Over on your linear pair word, you guys, come over here and remember that linear pairs add to 180. Two angles that add to 180. Let me actually just draw an example right in here. A linear pair is when you have two angles that lie on a line like that. And they would add to 180. That'll come up for us. And then the corollary to a theorem is a rule that follows from a theorem. And when we look at the next page, I'll explain to you how our corollary follows a theorem that we already know. There's two different areas that you have to look at triangles for when you want to classify them. And what it boils down to really is when we want to give a triangle a name, we have to classify it both by its sides and its angles. I'm going to jot that down in the notes. To name a triangle, it means that we classify it. We give it a name based on its sides and its angles. To name a triangle, we must consider its sides and how they are related. We must consider its sides. I'm not going to put and how they're related. I'll show you why. We must consider their sides. I'm going to go on, but I'm going to go up here into the names for sides. If you have no sides that are the same, it's called a scalene. And then if you have two sides are the same, when you get done jotting that sentence down, come up here. Two markings for two congruent sides is that isosceles. Two congruent sides is isosceles. And then if you have all three congruent sides and you see the markings for all three, all these are the same, that one's equilateral. So first one is no sides the same, scalene. So we've got to consider how the sides related, and we get a name for a triangle based on one of those. Don't throw my flower away. Anyhow.
You didn't take it yesterday.
No. That's funny. And so now I'm going to come back down here. To name a triangle, we must consider its sides and its angle measures. So we have to look at how the sides relate and the types of angles that are in the triangle. An acute triangle has three acute angles. You guys remember an acute angle is less than 90 degrees. An acute angle is less than 90 degrees. A right triangle has one 90-degree angle. We know what that 90-degree angle mark looks like. Obtuse, if we see a triangle that has one angle in it that looks like it's more than 90, and we'll actually be doing some measuring too. If it looks like it's more than 90, we'd call that the obtuse triangle. And then an equilateral triangle, equiangular triangle. Equilateral and equiangular are going to go together. If I have an equilateral triangle, it's also going to be equiangular, and the angles will all be the same. And I just heard Jamar say each angle would be 60 degrees. He's right. If they're all the same, we know the sum of the measures of a triangle to add to 180. So if they're all the same, they'd be 60 each. So we need to give all of our triangles a name based not just on sides, but also on angles. When you're ready to go on, turn your page. I'll come back to it after. Erica, would you hand him your top part for real quick? You can do that maybe. Just waiting a minute here while a couple of people catch up. I'm sure. I'm taping this because there's a videotaping this today because there's a lot of people not here. The roads in St. Clair Shores are really crummy. Like up by me in northern Macomb, like the roads weren't as bad. I got into Harrison Township, the roads weren't as bad. Down here in the shores, they're really crummy. Yeah, I just left. I had plenty of time, and I just drove slow. All right, I'm going to go on. Yesterday in class, okay, sorry, I think everybody had some time. Measures of the interior angles. we've got the triangle sum theorem. I want you guys to go grab a colored pencil. And this triangle sum theorem is saying if we take the measures of all three interior angles, they're going to add up to 180 degrees. We messed around with this yesterday on the TI Inspire. I'm going to make a little note about that. We used the Inspire, it's actually N-S-P-I-R-E calculator, to test this on, I'm going to put yesterday, because we all remember doing this yesterday, right? I'm just saying that. Yeah, that's right, yesterday. Now, if you're not convinced, and I'm going to show something here, and I'm going to freeze my screen for kids in class to do this, and then I'm going to show a couple things. If you're not convinced about triangles having a sum of 180 degrees, or you think it's something that might take you a little while to remember, I'm going to show you a few examples here. Again, I'm frozen on the screen for my kids because I'm going to use a couple triangles here in a second to show you what I mean. We used to test this yesterday. TI Inspire calculators that we used to test this. Inspire. That's the kind of calculators you had in your hand from Miss Principato yesterday. The high-tech ones, yeah. Now, we know that a line, I'm going to use my ruler right here just to represent a line. We know that a line measures, in terms of an angle, it measures 180 degrees. Now, I want you guys to check out this triangle, and all I did was took a red colored pencil and shaded in the angles like I did in the drawing. And just to show you guys, and I think this is helpful and can be convincing, I just tore up my triangle. And when I go and piece these three angles together, just as a visual proof to maybe help you remember, the three angles come together and what do? They lie in a line. There's the 180 degrees. If I take it with any shaped triangle, like here's another one. This is actually a right triangle. And all I've done is just highlighted the angles, the interior angles. And if I just go and take my triangle apart, no matter what, I can put those angles all together and they're going to give me that 180 degrees. So just another thing that would help you to remember that. It's kind of a silly example, but I think it helps. Now, I'm going to grab a different colored pencil for the theorem 5.2. This is the exterior angles theorem. And the definition of exterior angles was a little bit odd when we wrote it on the other page. Exterior angles are formed, they're a linear pair with a side. Now, I'm going to grab a different colored pencil. I don't want to be shading my exteriors the same as I was the interiors. But an exterior angle is like this one right here, angle 1. And I'm just going to kind of lightly shade this angle 1. Angle 1 is exterior. Now, cool. Hey, good morning. Angle 1 is considered to be exterior. Everything that you need is on that table up there, sweetie, when you get your bag put down. This theorem is telling us this. Now, I'm going to explain this, and I know I'm going to probably have to come back to it a couple times. But if you guys take a look-see here at angle 1 and what I'm doing with my pencil, this exterior angle and this interior angle are going to add to 180. This exterior angle and this interior angle are going to add to 180. The theorem is telling me that this exterior angle 1 is going to be equivalent to the sum of these two measures. If I add up the two interior angles that aren't part of the linear pair, they're going to be equal to this exterior angle out here. If I add up the two interior angles that aren't the angle with the linear pair, it's going to be equal to the exterior angle out here. How can I say this in words? An exterior angle is equal to the sum of the interior angles that it doesn't touch. The two other interior angles, there we go, the two other interior angles that it's not paired with or it doesn't touch. And I'm going to put them both. An exterior angle is equal to the sum of the two interior angles that it's not paired with. It doesn't touch them. These two inside equal the one outside. And of course, we're going to mess around with this and do some examples together. Nick, the beginning of this lesson is going on my YouTube page. There's just a lot of kids coming in late today. Now, the next one, this idea of a corollary to the triangle sum theorem. The triangle sum theorem is the one that says the three angles in a triangle add to 180. The three angles in a triangle add to 180. That's what that says. Now this theorem goes on, and I think it makes a whole heck of a lot of sense. If you've got a right triangle, we already know one of the angles is 90. If we already know that we've got one angle that's 90, so I go, okay, 180 minus 90 for the right angle. That leaves me with 90 more degrees. This is going to be the sum of the other two angles. I'm going to use my interior color. If one angle is marked 90, the other two add to the other 90 degrees. Those two together give me 90. And just don't forget that that's called complements. If one angle in a triangle is right, the other two angles are going to be complements of each other. If one angle in a triangle is right, the other two angles will be complements of each other. I'm going to continue with a separate video of the extra practice just so I can start uploading this.